Be learning about scientific notation, which is the notation that allows us to write really large or really small numbers using powers of 10. This video is about 15 minutes. However, a large part of that is you tries where you pause the video and you have to try them yourself, and then there's an explanation. So you can use fast forward to get to the answer and then rewind if you don't get the answer correct. However, if you get the answer correct, there's no need to rewatch the explanation. You can just move on with the video. So the goal is to be able to write scientific notation numbers in standard form numbers in scientific notation, and to multiply and divide numbers that are in scientific notation and write the answer in scientific notation as well. Have fun! So when you see a number, you know that it's in scientific notation because it has a number between 1 and 10, most of the time with a decimal point there. If it was like 2 times 10 to the 8th, you could write it as 2.0, or you could just write it as 2. Number between 1 and 10, and then 10 to a power. So you have a power of 10 that you're multiplying a number between 1 and 10 by. As we know, powers of 10 move decimal points, so a positive power of 10 will move that decimal point to the right, making the number larger, and a negative power of 10 will move that decimal point to the left, making that number smaller. So the exponent on the 10 is 8, so I'm going to take the existing decimal point and I'm going to move it 8 places to the right. And when I do that, I'm going to have 7 holes to fill with zeros. Notice there are not 8 holes to fill, there are only 7 because it took 1 power of 10 to get from 2.4 to 24. And then you're going to write the number without the decimal point, so it looks like a very large number as opposed to 2.4 with a whole lot of zeros at the end of it. And then you're going to put your commas in every 3, 6, 7, yep. So 240 million. When you have a negative power of 10, you are going to move the decimal point, the number of places in the power of 10, but because it's negative, you're going to move left. So in this case, you're going to go 4 places to the left, and your decimal point's now going to be in the front of your number because you're talking about a decimal that is way smaller than 1. Remember that the power of 10 tells you how many places to move the decimal point, not how many zeros there are in the number. When you look at the negative power of 10, you may be thinking to yourself, we're not supposed to have negative exponents. It's not fully simplified. And I would agree with you. Scientific notation is the only time that will allow you to have a negative exponent. Remember that a negative exponent would be saying, if I had 10 to the negative 4th, that would be saying 1 over 10 to the 4th. So it would be like dividing by powers of 10, which is why your number goes from 3.5 to 0.00035, because you are dividing by 10 to the 4th. The first thing this video showed you how to do is how to take a number that's in scientific notation and write it in what we call standard form, which is an actual number. And now you're going to look at how to take a number that's already in standard form or an actual number and create a scientific notation representation or an equivalency for that number. So we know that if you have a number where you don't see a decimal point, the decimal point exists at the end of the number, and you are going to count in until you get a number between 1 and 10. Well, if you go 1, 2, 3 spaces, you still have a very large number. Another 3 spaces, you still have a very large number. Another 3 spaces, you now have 68. 68 isn't between 1 and 10, but 6.8 is. So I know that the only number that I can create that is between 1 and 10 is 6.8. If I go to the end of that number, I would have 0.68, and if I stop too soon, I would have 68. Now I know it's also a power of 10 because powers of 10 move decimal places, and now it's my goal to figure out how many times I just went in from the end of the number to get between the 6 and the 8. So if I count my loop-de-loos or how many places I went, 3, 6, 9, 10. So I know that 6.8 times 10 to the 10th would give me 68 billion. Remembering on the last slide that negative exponents result in very small numbers, less than 1. Our goal is still to figure out the number where we can move the decimal point, which will create a number that's between 1 and 10. If I go here, no, 2, 3, 4, 5, now I have 0.45, 4.5. Okay, there's my number. And if I went one place too many, I would have 45. And I know that's going to be a negative exponent. I have to figure out how many places I move that decimal to get between the 4 and the 5. So I went 1, 2, 3, 4, 5, 6 places. So I know that it would be 4.5 times 10 to the negative 6, which would get me that small number. So right now it's a good idea to pause the video and try these two problems. You can use the back or the front or any space on your video worksheet to do so. You don't have to watch the entire explanation on how to get the answer. You can just fast forward to the answer and then rewind back if you didn't get the right answer. So I'm going to write these numbers in standard form, which means that I take my 5.2 to times 10 to the 6th, and I move my decimal point 6 places. So I went 1, 2, 3, 4, 5, 6 places. I fill in my empty 5 places with zeros, and I have 52 with 5 zeros. I remember to rewrite it so I don't have an existing decimal point there, and then I put my commas in, and I have 5,200,000 as my answer. Again, I write 8.2. I know it's to the negative third, so I'm going left this time. 1, 2, 3 spaces. I fill in my zeros, and I rewrite my number so it doesn't look like I have 2 decimal points. If you got these, then you know how to go from scientific notation to standard form. So on this slide, again, pause the video and try to write these numbers in scientific notation. Realistically speaking, you're not going to ever have to write 230,000 in scientific notation because it's not a large enough number to do so. But for right now, to practice the skill of taking a number and writing it in scientific notation, it really doesn't matter how large or how small the number is. So pause the video, go ahead and do them, fast forward to your answers, and then if you get them right, you can keep going. If you didn't get them right, rewind and see how I did it. So my goal is to get a number between 1 and 10, so that would be 2.3 would be the only number that would, in this number right here, where I can move a decimal point and get a number between 1 and 10. I start at the end of the number and I move my existing decimal point, which I don't see because it's invisible, 5 places in. So it would be 2.3 times 10 to the 5th. For this decimal, my decimal point is going to be 3.45. because that's the only number that I can create that will be between 1 and 10. And I know that it's to a negative power of 10. So I went 1, 2, 3, 4, 5, 6 places. So it would be 3.45 times 10 to the negative 6. So if you're given 2 large numbers in scientific notation, instead of writing them all out and doing your enormous multiplication problem that this would create, the only thing that you have to do is multiply the numbers that are in front, which in this case are 4.2 and 5.8, which gets you 24.36. And then the bases in this case are 10, so I keep the base the same, and I use my exponent rules, which we've been working so hard on, and I get 10 to the 18th. That is not in scientific notation, though, because the first number that I got when I multiplied 4.2 times 5.8 is not a number between 1 and 10. The beauty of that number is I can move the decimal point 1 place to the left, which means that I am moving it 1 additional place to create a number in scientific notation. So my final answer would be 2.436 times 10 to the 19th. I'm not going to make you write 2.436 times 10 to the 19th in standard form. That would be a lot of zeros. But what you do have to know how to do is take the numbers in front, which I'm air quoting as coefficients. They're not really coefficients, but we'll treat them as such. And that in a multiplication problem, you're going to multiply them, and in a division problem, you're going to divide them. Then you're going to keep the base, which will always be 10 in a scientific notation problem, the same. And in a multiplication problem, you're going to add your exponents, and in a division problem, you're going to subtract your exponents. If in this problem, when you multiplied the two numbers in front, the number did not exceed 10, you would leave it alone. So if you happen to have a number when you multiplied the two numbers in front and you got 8.6, you would leave it as 8.6 times 10 to the 18th, and you wouldn't have to mess with it to get a number between 1 and 10. You only do that when the number exceeds 10 or is less than 1. In the second problem, when you divide the numbers in front, which are 2.5 and 5, you get 0.5. In addition to that, you keep the base the same and you subtract your exponents. So now you have 0.5 times 10 to the negative 3. Well, 0.5 is less than 1. So in this case, in order for me to get a number that is between 1 and 10, I have to move the decimal point to the right one space. So I'm going to get 5, or 5.0 times 10 to the negative 4th. If how I am moving the decimal point and increasing or decreasing the exponent doesn't make sense to you, you could take 0.5 times 10 to the third, and knowing that it's 10 to the third, you could move it 3 places. Because the negative 3 still tells you to move the decimal point 3 places to the left. And when you do that, you get 0.0005. So if you were to take that number, which is now in standard form, and you were to rewrite it correctly in scientific notation, you would never have stopped between the 0 and the 5, because that number isn't between 1 and 10. You would have taken one extra step to the end of 5, because 5 is the only number that is between 1 and 10. And in that case, you would have gone 4 spaces, not 3 spaces. So if you were ever stuck as to which way, whether to add 1 or to subtract 1 from your exponent, then just write out the number. The rule is if you go 1 space to the left, you add 1 to the exponent. And if you go 1 space to the right, you subtract 1 from your exponent. So here are 3 more problems again. Fast forward to the end. After you do them, see if your answers agree. And then if they don't, rewind and see how I did it. There's no need to watch my explanation if you've done them and your answers are correct. So I do the first problem. I multiply the numbers in front, 5.8 and 1.3, and I get 7.54. I keep my 10 the same. It's a multiplication problem, so therefore I add my exponents. So my number in scientific notation after I multiply 5.8 times 10 to the 13th and 1.3 times 10 to the negative 4th is 7.54 times 10 to the 9th. In this case, I'm done. 7.54 is between 1 and 10, and 10 to the 9th is a perfect power of 10. The second one is like the first one in that they're both multiplication problems, except now when I multiply 6.3 and 4.8, I get 30.24. I keep the base the same, which is 10, and I add my exponents. 30 is a bigger number than 10, which means I have to now move my decimal point 1 place more to the left. So I get 3.024. And then because I moved 1 additional place, it means that if I wrote out my number really long in standard form, I would have to go 1 more space to the left, which means it would be to the power of 10. So I'm moving my decimal point to the left, so I'm adding 1 to my exponent. In the final problem, when I divide 1.2 by 4.8, because it's a division problem, I get 0.25. When I subtract my exponents, I get 10 to the 5th. 0.25 is less than 1, so I move the decimal point 1 additional place to the right, which would give me 2.5, which is a legitimate number in scientific notation to have as my first number. It is between 1 and 10, and now I subtract 1 from my exponents. So for those of you who don't understand, I'm going to write out this number for you. If I had 0.25 times 10 to the 5th, it would mean that it is a positive exponent, so I'm going 5 places. So I have to go 2 places just to get to the end of the number, and then 3 more places, which would give me 25,000 as my number. So if I have 25,000 as my number, that looks like an 8, 25,000 as my number, and my goal is to write it in scientific notation, I would only move